Strings Revisited. Thus far we've had one complete nugget dealing with strings, and we've referenced them in just about every other nugget. However, we're now going to take our understanding of the string data type to the next level. First, I'm going to show you the advanced string methods, ways that you can do lots of interesting things with string data. Perhaps you need to trim off left hand, right side, or both side padded space data on certain strings. Well, you can do that. Suppose in your code you need to make sure that all user input gets formatted as uppercase only or lowercase. These are all simple examples of things we can do by employing Python's built-in string methods. Next, we'll look at another way to take string data and personalize it. This is string formatting, and it's one of several techniques that has undergone quite a bit of change from Python 2 to Python 3, so we'll want to make a note of that when we reach that point of the nugget. Third, we'll formally describe the input function. This is the chief way in Python that we can prompt the user to enter some data at the keyboard and then retrieve that input as a string to perform further processing on it. Without any further ado, let's get to work. String methods. You'll note at the top of this whiteboard I've given you a URL pointer to go into the Python version 3 online help, into their library subdirectory, and there's a page called Standard Types. Specifically, in this Standard Types article, there's a bookmark, section 5.6.1, called String Methods, that gives us a really nice list of all of the methods that we can apply to string objects. A lot of them are pretty self-explanatory. For instance, the capitalized method is going to return a copy of the string with only its first character capitalized. Count, we can change the encoding of a string. That may be useful, for instance, if we want to take strings and move them from the default Unicode and bring them back to ASCII for whatever reason. Find, format, some of these we've looked at already, but a lot of them are brand new. I just wanted to give you a heads up to this page so again you would know where to go to look up this information. You're probably more than sick and tired of my saying this, but remember, string data and numeric data are immutable. And I've come up with a diagram here down below that I've created using Microsoft Visio that I hope really drives home a couple of points. The immutability of strings, and also, again, that difference between the name and the object. So let's take a look at this diagram. We'll look at the first line first, reasonably enough. We're creating a name called A, and we're assigning the string value ABC to it. A is the variable, or the name. ABC is the data object that dynamic typing tells us, of course, is going to be a string. Now, we've said many, many times that string data is immutable. That is, we can't change this data object. If you tried to run A sub 1 and change just the one position in the index to something else, maybe D, you're going to get an error from the Python interpreter, you see. On the other hand, what can confuse you at first is it appears that you're overwriting the original data object if we then, for instance, assign A to a new data object. In this example, A plus ABC, which is going to wind up with ABC, and then actually this is a small typo. It should be ABC, ABC. The point that I want to make, friends, is to repeat that although we've taken A, the single name, we've pointed it to a new data object, ABC, ABC, basically. The old object still exists in memory. Now that's important that Python keeps a track of this old data object because there may be references to this data object that still exist in your code, you see. And actually, that's how Python garbage collection works, by looking for data objects whose ref count, or number of references, has gone down to 0. We're going to demonstrate some advanced string methods by first of all creating a name, I'm calling it str1, that gives us this string literal called this is a sample string. And now what we'll do is begin to manipulate the string, manipulate the data object. Specifically, the first thing I'll do is do an str1 dot, and as we know by now, this brings up the methods that are attached to that member, to that name, which of course, to again extend our knowledge, dynamic typing is that these are methods that pertain to strings. And I'm going to make sure that I'm arrowed over capitalize. And here's a better tip. In the past I've told you that you can strike the tab key to select one of these methods. What works better at least it's a little bit faster on my PC, is to use the space bar instead. So just to let you know. Now some of these advanced string methods don't have any arguments. You notice the online help tells us that capitalize simply runs and it outputs a string. And what it did here, capitalize, as I told you earlier, it takes the first letter in that string and it capitalizes it. Now let's do an str1.count and we'll pass in a substring, or a substring range really. We'll look for is. Once again, it helps if we refer to our name correctly. Change that to str1. And it tells us that there are 2 instances of is in the string. Now this is one of those things where we want to be not so reliant on what our code is. In other words, if we're completely convinced that we're calling this method properly, we want to still go back and check to make sure what's actually being done to our name. And that's yet another thing in favor of using the interactive interpreter in your development. Because when we look at the words, of course, is only occurs once, and perhaps in our program that's literally all we would want to bring back. But because this count is looking at just those 2 characters, you'll notice that THIS space IS. You see what I'm saying? So there's various ways that we can accomplish this. Perhaps the most logical one is to look for the string literal is with spaces in front of it and behind it. This just gives a reference of 1. So whereas count is a nice method for looking at the number of occurrences of a particular substring, we can also try find, which will give us the index position of the first occurrence of our substring. So if I look for the substring AMP, it tells us we're in position 11. Now let me echo back string 1. If we count from left to right, I'm here to tell you that amp and sample is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, sure enough, position 11 in that string. With both strings and numbers, you can use several varieties of is methods. For instance, we can do is upper to do testing, really. That's what the is command is used for. And is upper, very simply, comes back Boolean true, Boolean false on whether a particular string is in uppercase. Of course, that comes back false. If you need to force a particular case, like upper or lower, you can do that just by passing in, respectively, upper or lower.